Okay, dear guests, dear colleagues, we will now start a second session at our 8th Engineering Geology Challenges conference in Łódź. We are really glad to have you here in the room, and we will now start our international workshop, Urban Geology and Geotechnics. This workshop is organized by two organizations that their chairmen or presidents invited themselves at the beginning. It's ELGIP, European Large Geotechnical Institutes Platform, and Eurogeo Surveys, Urban Geology Expert Group. The aim of this workshop is to try to bridge the gap between engineering geology and geotechnical engineering. So to show how geological surveys organizations that are in Eurogeo Surveys try to represent the city or regional scale approach to geology, or even more general geoscience approach, and how this can be interact with the site scale approach represented by geotechnical institutes and soil investigation companies. This workshop is also accompanied by our partners and sponsors. This is company Geot, SISGEO, and DATC. They will have a presentation and they have a booth at the expo. And we have also companies from Soil Cloud representing the geotechnical data cloud management services, and Guideline Geo, the manufacturer of geophysical equipment. They also have a booth. Today's workshop will be moderated together by me, Grzegorz Ryżyński from Polish Geological Institute, and with Peter Vandenberg, ELGIP Secretary and Scientific Director of Delta-Res Institute from Netherlands. Today's session, we have 16 presentations in 2 sessions. In the first part, from 11:30 to 13:30, we have 7 presentations. One of them will be online. Then we follow with the second session of the workshop from 14:30 to 17, 9 presentations, from which of them 4 will be online. 6 presentations are from Eurogeo Surveys, 5 from ELGIP, and 5 from partners. We also invite you to the booth and place in the expo area where info about Eurogeo Surveys and Urban Geology Expert Group and ELGIP is presented. And now, Peter, the floor is yours. I kindly ask you to moderate the workshop.
Thank you, Grzegorz, for this kind introduction. For me, it's a big honor to moderate this workshop here in Łódź. The workshop Urban Geology and Geotechnics, organized by BGI, ELGIP, the European Large Institute, Geotechnical Institutes platform, and the Eurogeo Surveys Urban Geology Impact Expert Group. Today, as also Grzegorz mentioned, geology meets geotechnics in engineering. Important, they both need each other to create sustainable solutions, effective engineering solutions. Geology describes the structure of the earth on and beneath its surface and the processes that have shaped that structure. Engineering geology, and in combinations with geotechnical engineering, uses this knowledge and other knowledge, of course, to solve engineering problems. And there are always, in the past, nowadays, of course, also in future, many engineering problems, different topics each time. Now it's more related to energy and climate, you know, and mobility and things like that. Especially in urban areas, everything comes together. The interaction between both geotechnics and engineering geology can still be intensified. They can learn from each other. And today we will listen to each other. And hopefully this workshop will contribute to bring those both engineering together. But let's go to the presentations. Grzegorz also introduced the presentations. We have a lot of presentations, so hopefully the presenters will stick to the time they have, maximum 15 minutes. And the first presentations will be given by Francesco La Vigna from Ispra, Italy. And it's called the Urban Geo Footprint Method and results.
Good morning again. So my presentation is about one activity we are conducting in our expert group that is a typical top-down process. So we started very general from the main characteristics, main geological features of cities in order to spread the knowledge and make citizens and city managers aware about the geological processes and the geological setting of their city. Before going on, I just want to say that today I am a frontman. Behind me there is a huge group of people collaborating. We have developed this tool together with this institution, the University of Granada, the British Geological Survey, the Instituto Geológico y Minero de España, the Geological Survey of Belgium, and the Geological Survey of Norway, but also with all the organization, all the surveys participating in the Urban Geology Expert Group of Eurogeo Surveys. What is the Urban Geoclimate Footprint that we can call, starting from now, UGF? The UGF is a new approach aiming to classify cities by geological and climate point of view. It works based on the decomposition of the geological and climate pressures insisting on a city in 4 natural drivers. You can see here the deep processes, the superficial processes, the geology in terms of the geological structure, geological stratigraphy under the city, the exogenous processes, and the subsoil anthropic pressure that is the only driver that we can define anthropic, so made by the presence of the people. The combination of these drivers produces some indexes and the city classification, allowing city clustering by similar geological setting. The easy-to-read results allow the increase of awareness of non-expert on urban geology matter and the exchange of best practices to support policymakers. So this is more or less a synthesis of what is it, the urban geoclimate footprint. How it works. Right now, the tool is a common Microsoft Excel spreadsheet, pretty complex, but basically is a spreadsheet. And we have 7 different sheets. You can see the blue in the diagram. The blue spaces represent the sheets of the tool. The user navigates between the sheets and, guided by the glossary, define the 22 parameters that are to be attributed in the tool. The final result is the city geofact sheet. So you have not maps. You have not something to be used by an engineer or in a project. We are generally defining the geological setting of a city. You have a fact sheet, a user-friendly document synthesizing the calculated indexes, the geological setting, and the level of geological pressure on the city, ready to be shared with the public. This is the city geofact sheet. This is an example for the city of Rome. You can see that there are some very simple descriptions of the geology or the city setting, some very general data, some maps, some cross-section or 3D model. But the most important thing is that based on the analysis made on the spreadsheet, you have some graphs and infographics automatically calculated by the tool. The first is this radar graph that is representing the magnitude of the different drivers in that city. So you can immediately understand which is the most important drivers affecting that city. And coupled with the radar graph, you have the classification system that highlights the two major drivers on the city. Moreover, you can find below a list of the 4 major parameters interesting that city. So not only the classification due by the drivers, but also the specifics on the single parameters on that city. Then another important point is the UGF score index, that is a number. So we have translated something that is from different categories, from different maps, from different studies and analysis in just one number. This number is a summation, is a number representing the geological complexity and pressures on the city. Last but not least, in the latest version of the tool, we have now this space at the bottom that is the job benefits. Why? Because we want to highlight that geology is not always a problem for the city, can be also a resource. So we highlight here 3 main elements characterizing that city that are the shallow geothermal potential, the geoheritage existence in the city, and the groundwater potential of the city itself. This is the results right now of the analysis made in the European continent. You can see we have 41 cities analyzed across Europe, and you can see that the cities are pretty spread. So we are pretty happy about this first result. Obviously, the work is in progress, so we are collecting more and more cities also now. You can see in this statistic analysis that how the UGF scores index vary from the lowest cities to the highest one. The lowest is Sisak in Czech Republic, and the highest is Naples in Italy. You can understand why. And you can see the variability of the drivers, the value of the drivers. Some of the drivers are very spread. Some are more or less with staying around the same values. And this is our first city clustering produced. So we identified 4 groups of cities identified by the 2 measured drivers as I presented before. And you can see that there are many cities that have similar conditions to be compared. And so they can exchange best practices to solve common issues. This is exactly the aim of our project, our tool. All this I presented is available in this publication, pretty recent, in the City Journal. So you can download this open access publication, and so you can find all the features I plotted before. Not only in Europe, Urban Geo Footprint is a tool that is not limited to the European analysis. We integrate the possibility to extend analysis also out of Europe, obviously referring to global databases. And we will soon receive some data from North America and Asian cities, also with the collaboration of other geological networks like CCOP for the Southeastern Asian countries. In conclusion, the urban resilience strategies identify many key aspects for cities to increase their capabilities of maintaining their functionalities, notwithstanding the challenges they are subject to. Behind visualizing the exposure to hazard geological and climate pressure, the UGF acts as a communication tool, revealing another key aspect, the invisible city's primary infrastructure, the city ground itself, along with subsurface resources and geological functions and their associated benefits. Last but not least, I want to close with our slogan, that is, be aware, be prepared, be safe. Because the UGF approach allows the general awareness of non-experts about the link between geological setting and the increase in pressures due to climate change and anthropogenic activity. Cities with similar UGF classification will be able to exchange best practices each other to solve or mitigate typical common issues. And the more aware and prepared citizenry is also safer, because it is more inclined to expect even the unexpected issues. And before thanking you for your attention, I just want to invite you to save the date of the 4th of December 2024. You are all invited in Brussels at the Royal Institute for Natural Science, where we will show the documentary we have realized in collaboration with the other geological surveys about the urban geology and the urban geoclimate footprint tool. Thank you so much for your attention.
Thank you, Francesco, for your very clear presentation. Thank you very much about the Urban Geo Footprint method or tool, and also the city geo fact sheet. It's very useful if there are problems in cities as a base to use. Thank you again. Okay, let's go on to the second presentation in this section, and that's given by Iulia Prodan, president of ELGIP, but also active at the Technical University of Cluj Napoca in Romania. And the title of the presentation is The Energy Below Our Feet and Its Potential for Urban Development.
Thank you, Peter, for the presentation, for the introduction. Today my talk is also related to urban development. I'm very happy for having the first presentation because it's to the topic that is to come, which refers especially to the potential that the underground below our feet, so the energy below our feet, is a great potential for ensuring local renewable energy sources for our communities. And we have seen in the past years how the pressure of the energy crisis has been developed in many countries across Europe. And it has been highlighted for all of us the importance of leveraging what we have locally and exploit at maximum the potential that we have locally. Today, my presentation in terms of urban development would refer especially to buildings and buildings development particularly. And I would like to draw your attention to the following subject, which is the foundations of the buildings or geotechnical structures. Now, geotechnical structures in general, when we refer to geotechnical structures, we refer especially to those types of structures that are in contact with the soil, with their primary role to ensure the stability and resistance of the building, of the surroundings, and so on. And when referring, it's very easy to imagine foundations of the buildings. Pretty sure everyone we would ask to what's the role of a foundation would be to sustain the building on top. Well, I'm here to say to you today that the foundations, in addition to their role for stability and resistance, they also have another opportunity and great additional value that could be added, which is that of creating with them renewable energy sources. This is what we call in geotechnical engineering energy geostructure technology or energy geostructure systems. What does this mean? It means in practice, it's, I don't know why the presentation looks like this. It's not the original, it's a little bit overlap, but okay. Not sure if it's the, maybe. Okay, anyway. So coming back, energy geostructures is basically in practice, it's very easy concept when you see it with your eyes. It's basically attaching pipe system to the rebars of the foundation when it is constructed, and then that's how you further on connect it to a heat pump, and it becomes the source for heating and cooling of the building, heating and cooling supply for the building. It can be implemented in a variety of types of structures, like underground parkings, like metro lines and stations, retaining systems of large variety, foundation systems on piles, and so on. Basically, the entire concept of this technology relies on the fact that soil is basically a magnificent shelter, which means that whatever temperature we may have outside, whether if it's winter, whether if it's summer, inside the soil we have a comfort temperature that we can leverage, and we can transform that through the foundations of the buildings into renewable energy sources that are there locally and that could create independence in terms of energy for heating and cooling for buildings. Now, I would like to point out also a major advantage of these types of solutions, which is the fact that energy geostructures, they are, let's say, a part of the shallow geothermal energy solutions. But the innovative part of it is the fact that we do not need to make additional investments in creating geothermal boreholes or other types of investment in order to have this source. We need foundations for every building that we construct out there. So leveraging this potential of foundations and transform them also in renewable energy sources is an amazing added value from many perspectives, both financial, sustainability, and so on. What I would like to present to you, just to show you the readiness of the technology, is the history of, or the story of two hospitals that we have implemented in Romania with my company, Greentex, which is currently the only company in Romania designing and implementing these types of structures, but also with the team from the Technical University of Cluj, because part of these projects have also a strong research component in trying to analyze the real operational behavior of these types of systems. So the first one is really the first hospital, because they are both hospitals. The story started with the need for retrofitting of the existing building of the hospital, and then the need for construction of an additional building right near it. That through the investigations, geotechnical investigations revealed that we do have issues with the foundation soil. High compressibility, and thick layers of that soil. So piles were the immediate solution for foundation. So what we have done, we have designed a pile foundation, but a little bit of more atypical system, which was isolated foundations on piles. Usually we do these types of piles with a big slab, and then below the slab go the piles. But here, for a variety of reasons, also in terms of optimization of the cost and so on, we went with this atypical foundation system, and we designed 230 piles that we transformed them into energy piles, and they went up to 10 meters depth, a depth that, as you can see, it's quite shallow when we talk about deep investigations in terms of soils and so on. However, it was more than enough to transform this foundation into the energy source for heating and cooling of the hospital. We had, due to architectural reasons, a variety of configurations, and then this was the concept, and we moved to the design stage, where it's important to mention, and I would like to make a parallel here, between what it is needed in terms of input data for designing this type of systems, and then what is it that we do in geotechnical engineering when we design this type of systems. Because usually when we design a foundation, and I'm sure you all know this, we need the input data, which is the geotechnical investigations, geotechnical parameters, physical and mechanical parameters of the soil. And this is usually what concludes geotechnical design of a foundation? Well, for energy geostructures, we do have additional 2 other steps, which refer, the next one would refer to the energy design of the foundation, and that means that we need to quantify what's the amount of energy that the foundation can produce for the building. And then the third one, to analyze the effects of having these temperature variations in our foundation for both mechanical perspective but also energy perspectives. So in terms of thermomechanical behavior, we do have a superposition of effects, but in terms of input parameters, and I would like to highlight here, in addition to the geotechnical parameters, having information from the soil regarding the thermal potential of the soil, thermal parameters of the soil, thermal conductivity, resistivity, and so on, is very important. Now, for this particular type of system that I showed you was a little bit atypical than the classical one. From the beginning, we wanted to make a correlation or parallel between the classical, which is the raft foundation, and the isolated foundations. We also made some assumptions in the design stage because we, based on the calculations, we managed to reduce the cost with more or less 30%, ensure a faster execution. However, we came up with additional challenges related to the foundation system, to the energy foundation system, in trying to understand what would be the additional differential settlements, thermomechanical behavior, and the energy performance of the piles. Because when you execute geothermal boreholes, you have certain parameters and distances that you need to have between the boreholes in order for them to perform well from the energy point of view. In the foundation, the distance between the foundations and the piles is not given by this. It's mainly given by mechanical reasons and structural design perspectives. So this definitely influences also the energy performance and is something that we assess in the design phase. Now, all the calculations went in parallel for the thermal-induced stresses, and then also for the settlements, comparing the isolated foundation to the raft foundation. I will not go into the really details of the geotechnical engineering of this, but just to say that in the design phase, we did see differences in terms of the behavior, how would the raft foundation on piles would behave compared to the isolated foundations. And then we went to the execution. These are some pictures from different phases of the execution. This is from when we executed the piles. Then this is the phase where we have to smash the top part of the piles to extract the pipes from the piles, and then further on connect them through the foundation and ensure all the lines until the heat pump. Now, as I mentioned, this was also part of a research project with the main purpose of trying to understand what is the real operational behavior of such system, both in terms of mechanical performance, but also in terms of energy performance of the building. And for this, we have equipped 8 piles with sensors at different levels, and pipes, different configurations to try to assess what's the influence in terms of energy performance. Now, important to mention, so this is the design, and then these are the results, first results after are now closing almost the 3rd year of the monitoring. And we have learned a lot of lessons that draw us back somehow also to the input parameters. How important the detailed investigation and the accuracy of the soil parameters is. We have seen also a large non-homogeneity of the soil also during the construction, and this has clearly impacted also some of our assumptions in the design phase. But for sure, having accurate data on both geotechnical parameters but also on thermal parameters of the soil is very important. Also, regarding the rigidity of the structure, and this is something that was interesting for us to see, is that basically due to the rigidity of the building that comes on top of the foundation, the different types of foundation, whether it is isolated or raft or whatever, it doesn't really make a difference in terms of thermomechanical behavior. And so implementing the energy system doesn't really make any significant changes in the actual behavior of the classical foundation, which is great news. because to create a source of energy and adding additional problems to the building. And that gets me to the continuation of the story, I would say, with the second hospital that came right on the right of the existing building immediately after we finished the first one. So we finished the first one in 2019, and then we started the project for the second one. Also part of the hospital, we started the execution last year, this time with a general rough foundation as final solution for the foundation of the building. But basically what we managed to do in the end is to have two hospitals that have their own source of heating and cooling only through their foundation. So the foundation covers for both of the hospitals 100% of the heating and cooling demand for the operation of the hospitals. So that brings me to my final conclusion into saying that yes, the ground for sure holds a huge amount of opportunities. And the ground below our buildings is a great opportunity for creation of local, independent, renewable energy sources. Thank you very much.
Thank you very much, Iulia, for your presentation about the energy geostructures. A great opportunity, as you can see here. And also I learned that soil is a magnificent shelter. Okay, thank you again for your presentation. Then we will proceed and go on to the third presentation in this session. It will be given by my colleague at Deltares in the Netherlands, Tom Peters. He is also the coordinator of a big European project which is called GeoLab. But now he will have his presentation on the use of geological databases in geotechnical applications. Some case studies. Okay, floor is yours, Tom.
Okay, thank you for having me and inviting me for this presentation. In this presentation, I will try to bridge the gap between geotechnics and geology. Yeah, I did this presentation together with some of my colleagues. The content, first I'm going to do a few slides on Deltares, because I think Deltares is sort of a unique institute in the sense that it is not government, it's not a university, it's an independent research institute. I will show you 3 showcases of this integration of geology and geotechnics, each 3 slides, so bear with me. So Deltares is a merger of a number of institutes, and we bring in 100 years of experience in the field of water and soil. What you see here in the picture is the closing of the Zuiderzee. It's a part of the North Sea. It's a bay in the Netherlands that was closed in 1932. And yeah, already predecessors of Deltares were involved in this project. And on the right side, you see the dike as it is now. It's fully revamped, so to say, improved again, and it's still there. Yeah, so if we look at Deltares more in depth, so we work internationally and nationally. So about 30% of our work is international work in all the continents, in Asia, in the US, in the Middle East, etc., etc. We have small offices that connect us to our clients and our stakeholders. We do projects for the national governments, but some projects for the World Bank or for European projects. We are about 850 staff, and it's good to realize that we are on soil and water, but I think about 200 of our experts are really working on the subsoil. So that is on one hand geotechnics, so offshore geotechnics, dikes, road, railway embankments, underground buildings, pipelines, all these things are covered by us. On the other hand, also applied geology and geophysics, and also groundwater. So we as Deltares always say we have the people, the staff, the expert. That's the most important, but we also need good tools. And one of it are the research infrastructures, of which you see an example here, the geotechnical centrifuge with an arm of 5.5 meters, which is used for geotechnical research. But we have many more facilities also in flumes and basins, etc. So now I'm coming to these 3 case studies. The first one is a housing project in the Almere city. It's a city on soft soil. So of course, a lot of times in the Netherlands we have soft soil, clay, peat, sand, and that requires a good knowledge of the subsoil. Let me say, so the Almere city is planning to extend with about 30,000 houses, and we have a big problem in the Netherlands with housing, so that's a good development, of course. What usually happens with spatial planning of such a new residential area is that it's looked from purely the spatial planning perspective. And what we have brought in this project is that you also need to look at this from a water and soil guiding principle. So we say, let's make water and soil more a guiding principle when you do spatial planning of such a housing area. And that's, I think, an important development, because the whole settlement of the subsoil and land subsidence will go on for decades, and it will also give a lot of maintenance issues in such a residential area. So what we did is we developed tools, and then we're getting to that, to do this. So in the Netherlands, we also have, like here in Poland, I understand, a big database of CPTs, borings, and other geotechnical information and geological information. And we use that, this enhanced bureau, we call it, and geotop model, to do an estimation of the settlements of after 30 years. So usually you bring in a sand layer and you start this consolidation process, and it takes a long time. And this is used for the spatial planning. So this, based on that outcome, you plan where you build your roads, where you put your houses, where the schools, all these details are filled in by spatial planning. And we see 2 outcomes. First, it's a more generative methodology usable also for urban developments. And of course, it helps with the master plan. The next step in this project is really going to what we call a digital twin. So really on a larger scale, operational model. This describes the subsoil behavior and is used for spatial planning. The second case is on sand extraction from the North Sea. The Netherlands have a long coastline, about 250 kilometers, I estimate, and we want to keep it in place. So we do a lot of extraction of sand from the North Sea and do sand suppletion on the coastline to keep it there. So it's a measure to protect our coastline. But it's also used for commercial purposes when you're building roads or other things. So what we see, of course, is a lot of threats: climate change, sea level rise, land subsidence. These are all things happening, and we want to optimize our extraction of sand from the North Sea. So then we get to some questions. Okay, where is the usable sand near the surface and easy to extract? At what depth do you encounter other layers that you don't want to extract? And there's also a lot of other activities in the North Sea, wind farms, shipping, cables lying there. So it's also a way to look for locations where it's suitable to do extraction without conflicting other activities. This project is done together, by the way, with the Geological Survey of the Netherlands as part of TNO. So here we, first of all, we use, of course, our database, the broad database with all the geological borings that are already there from the North Sea. We have done a lot of seismic survey to determine the layering. And then we make this connection between geological layering and geotechnical properties of the sand. And then we build a model with that so we can calculate the volumes and the different types of sand. And then we get to the end result. And so this is one scenario, because you work with different types of scenarios. This is one scenario where you can see the Dutch coastline, and in red are the locations where it's not so suitable and there's not so much sand you want to extract, and in the green areas there's a lot more. And this is used by our stakeholder, the Rijkswaterstaat, to optimize sand mining. And then I get to my last case. This is a case about a canal in the Netherlands of about, I think it was 25 kilometers or so, yes. And this canal is used for shipping, of course, and the canal was widened and deepened to allow for bigger ships to pass. After the project was run, we had a lot of damage in houses. You see some pictures here on the right side, where we even had to put up a structure against the building to support it, a support structure. Otherwise, it would collapse. That are the bigger problems, but also smaller problems like cracks in houses, and that sort of things. Also, complaints about more water in the area after next to the canal. Of course, this got a lot of media attention, so we had a lot of television crews filming all this and sending it out. And you get a lot of experts and people who say, oh, this is the root cause, or this is the root cause. So yeah, I wrote down a number of things that could be the cause, like piping, so water flowing under the dike, or the consolidation of peat, oxidation of peat, and other things. And our job was to investigate what is actually the cause, and is the damage related to the construction activities or not, or is it partially related, and in what area is it related? And it is, of course, a very complicated situation. You see here you see here. No, not here. Yeah, there. Here the canal, the water of the canal. The canal is above ground level, so you have dikes to keep the water inside. So the land here is lower than the water level. So you will always have a bit of water flow underneath here, underneath. Sheet pile wall, here's a road, and here are the houses. The subsoil, this is here a peat layer. But peat was extracted in the past. 100 years ago, peat was used for fuel. So what you see often is that the peat is away here, but here it's still there because there was the dike already. So here you see nicely that the house is founded on this sand layer, but sometimes it's also founded here on the peat. So these are all the things that we have considered, and then we did a really big investigation into the root cause. So we used again the geological database to get a first impression, but we did also a lot of additional work, like borings over here, laboratory testing. We even had at 20 houses, we made holes here to inspect the foundation of the house and to see how the foundation, on what kind of soil the foundation was resting. And we had also a monitoring system for groundwater and groundwater flow. And this was all used to look into the root cause. But we could say is that, okay, piping was not really a problem, but we could see that a part of the houses was founded on peat. And yeah, because of the different, the changes in the water, the groundwater, this did indeed influence the housing. So this led to a damage settlement arrangement between the local government and a lot of the house owners. And that is my last sheet. Thank you for your attention.
Thank you, Tom, for this presentation. 3 case studies in which all of them the geotechnical knowledge, geological knowledge is very important to understand what's happening, knowledge in the geological databases. And we use it a lot in the Netherlands, the link between the BRO model, geotop model, and also as a starting point for our geotechnical analysis. Then we will go on to our next speaker. That's Marta Szlasa from PGI here in Poland. She is active at PGI, but also active in ELGIP. We know her from there also. And the title of the presentation is Shallow Geothermal Potential Maps as a Tool for Sustainable Development of Urban Areas.
Good afternoon, everyone. My name is Marta Szlasa. I work for the Polish Geological Institute, which is also a Polish Geological Survey. And today I want to tell you about our project, Shallow Geothermal Potential Maps, and its role as a tool for sustainable development of urban areas. When we talk about role of ground source heat pump in sustainable development of urban areas in Poland, due to the roadmap of geothermal in Poland, by the year 2050, we are supposed to have 200,000 ground source heat pump installations. That gives in total 5.5 gigawatt of energy by the year 2050, which is a great input into the renewable energy sources energy mix. In Poland, we have some problems with air quality and smog, especially during the winter time, and the air pollution due to the coal heating can be lowered with the use of ground source heat pump. And to increase awareness, local societies should be informed about the benefits of ground source heat pump technology, and the state-funded subsidies should be provided. And in PGI, we make a project called Shallow Geothermal Energy Potential Maps that helps to boost safe development of ground source heat pump installation. And this, many of you, I hope that already know this project. If no, please come to our booth where we can tell you about it and show how to use it. And in this project, we create various of tools to estimate ground source heat pump potential all over the country, and we share it for free in our GIS website, where you can find maps and the points data. And this is our web browser, in which in geothermal specific layer, you will find all the necessary information, the point data and the maps covering environmental maps and geothermal potential maps as well, with the thermal conductivity maps on a various depths. Here you can see the example of Warsaw. You can use them as a GIS layer, you can download them, or if you prefer, you could use them as a already given set of map with all the necessary information. When we talk about the workflow of this project, it is important to notice that these maps are done on the basis of 3D models, geological and geothermal models that later on are parameterized with the thermal conductivity. And later on, they are calculated using Python scripts in the cell of 25 square meters. And the methodology of our project is available online, so you can download it and check it. And it is harmonized with the other Central Europe countries during the project Geoplasma. Thermal conductivity parameterization is done by our team in the field and in the laboratory using different types of method, mainly thermal needle and the thermal disk, and also steady state device. And if you want to know more about the parameterization, tomorrow morning, my colleague is going to have a presentation about the thermal conductivity parameterization. Here you see a set of maps for urban areas, for urban area of Warsaw. For each localization, there's a set of 13 maps, including thermal parameters and conflict maps that shows contradictions for borehole heat exchangers. So our role is also to increase awareness of sustainable development of this technology. When you look at the maps among whole Poland, you see that there is a there is a variation in thermal conductivity along the country. The more red, which is a better thermal conductivity, usually are in the mountains, where on the lowland with the green and orange are a little bit lower in the thermal conductivity parameters. I want to focus your attention on web browser with the 3D models made by the Polish Geological Institute, where you will find 3D models made for a different project, but also you can find their 3D model made for this specific project. So it's Geological and Geothermal 3D model. This one is made for the area of Krynica in the mountains in the south of Poland. And this model is a grid model specially prepared for the visualization in the 3D. In this web browser, you could generate virtual boreholes. You can check the geology in particular site, or you can even generate geological cross sections in the given area. And here is an example of 3D model done recently in the current project area. And it's a thin model, so it's made of, in general, triangles that allows us to visualize geology as good as we can. And when you look at the different layers, you could see that we can model small layers and the big layers interbedded. So it might also be applicable in the engineering geology, where a lot of different layers are interbedded. For the areas where we don't have enough geological data, for example, for the suburban areas where a lot of new housing is built and there is a demand for ground source heat pump, we try to fill in the gaps with the geophysics, which is a very useful tool for drawing geological boundaries. And we compare this geophysics on a different depths, and as I said, use it as a additional tool to visualize geology. And here I would like to tell you about a few examples of use of our data. This is the typical example of use, where for the same area you examine the thermal conductivity on a different depth. And as you can see in this particular area, the difference in thermal conductivity is about 20 to 30%. That could optimize your cost for borehole heat exchanger for even 1/2, which is a great number. But you have to be aware that this kind of situation where the thermal conductivity rises with the depth, it's not always like this. Because sometimes with the rise of the depth due to, for example, a large clay deposit, thermal conductivity might be lower. So please be aware that it's not a rule. Here's a case study of Warsaw, for which we have done our maps, and we have done the 3D model of geological and geothermal layers. And in the area of Warsaw, you can examine the geothermal layers in every area. And we want to show how urban areas can benefit from that models we developed. And here is a case study of Warsaw with the pre-investment cost estimation for a very big housing association that decided to go into green energy. And we have taken our models and our maps and thermal conductivity parameters, combine them with the housing association needs, and we did the calculation that shows how much of the energy can be taken from the ground. So our methodology was to take our 3D model covering all available geological data, look at the conflict maps if there are no contradictions for borehole heat exchanger. If there are no any, then we can follow. And then we have taken thermal conductivity maps for standardized borehole heat exchanger depths. And we combine them with the building needs we gather from the housing association. And we simulate a localization of borehole heat exchanger at the site. And what we get was building needs versus geothermal capacity. And we got different classes for each buildings. So there were buildings that were fully accomplished with the geothermal energy, and there were those who were who need more drilling or need extra energy sources for heating. It is worth to notice in Warsaw here you see buildings with the visualization of borehole heat exchangers. So as you can see, comparing to the height of building, it's very deep. It could be 100 meters, but it could be even 200 meters. As you can see in the city of Warsaw, where there are big differences in the geology, even in the one area, the geology matters. And this is the last example of the use of our data. For those areas where there are no maps done yet, we have done for the whole country point map of the thermal conductivity. And here we can see a case study of Łódź voivodeship that we are already, that we are now. And this is the point map with the estimation of the thermal conductivity based on the hydrogeological boreholes and its geology and the standards given by the ground source heat pump ground source heat pump association. And how can we use this map? Of course, more or less the same like the maps, but it's the point data. But they can be used as the pre-investment possibility checked. It could be used as the estimation potential of ground source heat pump either on the site or at the big area. But it also could be used as a high-level input into high-level documents for urban development. And just the small statistics from this voivodeship, you could see that more than 1,700 point data were analyzed with the mean about 2, and the standard deviation is 0.5, which is quite small for that particular set of data. And the most common value is 2.1 up to 2.3, which is in general good for ground source heat pump. And to sum up, I would like to tell you that shallow geothermal potential maps might be used in urban areas as a tool to improve air quality, as input to the local renewable energy sources development strategies. It might be used as a planning and cost optimization tool, and last but not least, as a tool for safe and sustainable development of the market of ground source heat pump. And that's all from me. As I said, if you are interested in the specific data or you haven't checked this data yet, please come to our booth and we will try to help you. Thank you very much.
Thank you very much, Marta, for your presentation on the shallow geothermal potential maps and to share with us some examples of use. It was very useful. Thank you for this overview and this presentation. We only have 2 presentations left before you will have your lunch. And both presentations are partner presentations. And the first one will be given by Gianluca Vigna from SISGEO. He's already there, and he will show you some information about methods for soil drilling and grouting, general notes and specific applications for monitoring instrument installation. Gianluca.
Hello? Yes, thank you. My name is Gianluca Vigna. I'm a geotechnical engineer. I work for SISGEO, that is a company specialized in Italy to produce geotechnical monitoring instrumentation. But my backfield was an application field because I was a producer of drilling and grouting machine. And now I want to transfer in SISGEO my experience because there is a huge connection between grouting and drilling activities for the setting of geotechnical instrumentation for monitoring. Usually, the drilling technologies are defined by some parameters, mainly the purpose of the drilling, the scope of the drilling, the type of the soil that need to be drilled, the presence of water under the level, the drilling length and the meter, the logistical working condition that limit the dimension of the drilling rigs, of course, the diameter and the tip of the tool that I have to insert inside the borehole. If I have to insert fiberglass, tuba manchette, micropile, tie rods, but not only, we also monitoring instrumentation. And also the accuracy that I have to put in the deviation that I have to respect for the technical specification. The grouting mixing are defined by other parameters. The method and the pressure that I have to perform, the mechanical and the physical features of the mixture of the grout, the water cement ratio, that is the main parameters that we have to follow, the automatic or manual control system of the grouting parameters that are flow rate, pressure, volume mainly. The use of special component. We can use a special cement, microfine cement, pozzolanic, different type of mixtures. And the use of additives. The setting time is another parameter. If I have to give quick set to the grout, I have to use a special device and special additives. The advancing method regarding the drilling methods are mainly 2. We have other systems, but I have to concentrate on 2 different methods. The first one is rotation, on which I have a rotary head and a chain that pull and torque the rods that transfer the drill bits inside the hole. So the rotary give these 2 movements, the rotation and the pull. Otherwise, for this different type of soil, for stiffer soil, I need to introduce percussion. The percussion is made by hammer. The hammer, we have 2 types mainly of hammer. We have the top hammer that is placed on the top, so on the rotary head. And we have, for more energy system, the down the hole hammer that are moved by compressed air. And so I need to introduce on job site also higher compressor. In this case, we have a rotation, advancing, but also the vibration and the energy on the hammer. The drilling fluid can be different in drilling. We can have different drilling fluid. We need the drilling fluid because the drilling fluid help us to transport the cutting from the bottom to the top of the hole. We have to lubricate and cool the drilling and the coring tools. We have to move in the case of down the hole hammer, the impact mass that give energy to the hammer. We have to support and to waterproof the borehole internal walls. Generally, we can use water, we can use air, we can use grout mixture for self-drilling application, and we can use bentonite mud or fluid polymer. The water usually we use for rotary drilling with the cutting tools, the standard drilling without or with casing. We use, of course, for core drilling, also for wireline application. We use for jet grouting drilling. We use also for jumbo drilling. We use jumbo inside the tunnel to place instrument, but also to place dynamite for the drill and blast technology. We use hair for down the hole hammer application, but not only, also for the rotary drilling in loose soil, we need the higher lift up for the material sometimes. We use grout mixer usually for self-drilling system to tie roads, self-drilling, and also for the high pressure application of self-drilling that we call mini jet. Bentonite mud or polymers are used for water well drilling, are used for geothermal drilling, and for jet grouting drilling in some special condition with open gravel and open materials. We can drill without casing. If the soil consent it, if the soil is stable, we can drill without casing. The drilling tools usually are differently in function of the soil that we have to drill and also for the feature of the soil, of the drilling length and diameter. We can use, for example, drag bit that are very cheap for soft soil, 3 blade, 4 blade, 2 blade. We can use Tricon rock bit millet tooth for soft medium soil. If we need to improve the strength, because we have a weathered rock, we can use a Tricon bit, but with insert of carbide tungsten. We can use in some case for gravel and difficult soil, this type of claw bits with insert that can be replaced. For rock, we have the possibility to drill with special plates of synthetic polycrystalline diamond that are very strong with a great advancing performance. Is not cheap. If we are going to core, we can core with diamond core in rock or with the core carbide tungsten insert soft core, soft soil coring. If we want to use the hammer, as we told, we have down the hole hammer with compressed air working or top hammer hydraulic working. And here we have some reference diameter that we can use. If we want to drill in different soil when we cannot use the single rotating mode, we have to use casing pipe. So if we have problem of stability, we have to use casing pipe. What it means? It means that we have to use a dragging system to perform the drilling using the drill rods, but also using an external pipe that I leave inside the hole to place inside that my instrumentation, my pipe, my drain, what I have to put inside the hole. We have several systems. The main one can be the dragging from the external part, and this can be applied with rotation or auto percussion system. We can use for top down the hole hammer eccentric system to make rotate the rods together with the external casing. We can use other system on which we drag from the bit the casing without rotation, rotating only the inner part with the hammer. This is a symmetric type for auto percussion, but we have a huge, wide production on the market that we can use. The choice of the drilling diameter. This is a table that we working on it in SISGEO because our application need to decide in function of the instrumentation we have to apply the correct system and the correct diameter. So this is a list of the all the case of instrumentation that SISGEO need to put inside the hole. Now, I don't want to read you the table step by step. I want just to make you a sample how to use. This is a table that is available on our website and on our manuals, so is free for everybody that want to know. The case, we have to set inside the hole the casing ABS 70 for inclinometric application with kick-click joint. We have to check on the datasheet and we will see, together with the table I showed you before, we have a diameter of the pipe. We have the diameter of the joint, and we can find them inside the table. The diameter of the pipe is not relevant because we have to consider only the bigger diameter that we have, that is the diameter of the joint, 84 millimeters in this case, on which I add the diameter of the grouting pipe that you have to consider that to put inside the hole together with the casing. So total diameter real for our consideration is 104 millimeters. In case of drilling without casing, we can give minimum diameter and suggested diameter. In case of drilling with casing, I can give you but the solution, a minimum diameter and a suggested diameter, of course. If we want to pass to the grouting method, we have to start discussing about the component of the mixture. We have generally two components that starts to produce the grout, the water and the cement, that are usually managed by the water-cement ratio that is, my experience, close between 0.3 to 2.5, but we can find also different values. In sometimes we have to add bentonite mud that we need to pre-hydrate to give the features of the bentonite to the mixture, so plasticity, stability, and etc., etc. Use the additives that can be accelerating or retarding, that can be fluidifying, especially for the mixture with a very low water-cement ratio. And we can use expansive additives, but not only, polymer and stabilizing additives. Usually, the grouting mixture are defined by some parameter that we can check after the mixing. The water-cement ratio is input data. The virtual percentage of bentonite on the cement is another input data. The third data of input is the percentage of additives on white cement. Each of these components have a specific density that we can use to evaluate the feature of the mixture that we have to collect and to get. How we can check? With three methods. The specific weight can be monitored by mud balance and is a density, so kilograms on liters. The viscosity, we can use the Marsh cone that has a small nozzle calibrated on the bottom part and is measured usually in seconds. And the bleeding, so the percentage of water that separates after some hour from the setting. And this is measured by graduator cylinder that is expressed in percentage. The mixing starts from a mixer, of course. The mixer usually is like a tank with a shaft with some blade that has rotation of from 10 to 280 RPM, but I suggest a different approach and better solution. The turbo mixer is in the same situation, another tank, but without a blade, but without an impeller pump, with high turbulence that make a recirculation of the fluid and the powder inside the tank. We have a better quality of the mixing. We will have less mixing time. We have the possibility to work with silos, placing under the feet of the turbo mixer some load cells in order to weight what we are going to mix. After the mixing, the grout mixture go to agitator's tank only for storage and to avoid separation and segregation of the component. The pumping is in function of the purpose that we have to do. If we are going just filling or backfilling, so we need a big flow rate and not necessarily big pressure, we use big duplex pump or triplex pump that are more stable but with lower pressure. Lower pressure we have again with progressive cavity pump. And usually the feature of this type of pump are large piston diameter in order to have high flow rates. In case of backfilling, we need also to warranty high pressure because we have loss of weight during the pipeline. And we need also to have the management for the pressure and the flow rate of the pump in order to manage during the pumping activities. If we are going to do grouting or waterproofing activities, we need a smaller diameter plunger pump. In this case, the duplex plunger pump are the better one. Small piston to better control the parameters, hydraulic control of the valves, flow rate and pressure, and possibility to control these parameters through electronic device to data logger. If we are going to perform jet grouting or mini jet, we have to have on site a special pump. The jet grouting pumps need to reach up 450 bar, the mini jet little bit less, up to 250 bar. For the application inside the hole and for grouting activities in the setting of monitoring instrument, we have a good ISO standard that help us to manage this operation. They give us many key points. We can use additives. Each type of additive can be used, but we have to priorly analyze the inducted physical and chemical effect. Very important because this evaluation needs to be written clearly in the installation report. The text of standard gives us some mixed design in order to make grout in the same features of the surrounding soil that we have to investigate. We can follow this indication, but the ISO standard recommends to use experience and our knowledge in base of the condition that we have on site. So don't lose by your mind that you are the better medician for the application that you are going to do. The controls of the parameter. Before to install the instrumentation, we can check some parameters just during the drilling and the grouting activities. We can collect some very important information that are very interesting if we want to cross that together with the monitoring instrumentation data that we collect after. The first one that I suggest is the duct test that we can use also for core destruction drilling. Duct test, it means that I have to record and to consider all the drilling parameters, advancing rate, speed, the rotation torque of my drill rig, the push that I have to apply to drill, and the rotation speed. Crossing all these parameters, we can calculate the soil-specific energy that we can represent on graphics for each layer that we drill through. Of course, if we want to see what happens inside the soil, we have to recover the coring in the box. We can give a stratigraphic description. We can give rock quality design for the description of the quality design of the rock or the materials. We can make preliminary tests on samples, and we can collect samples to send on laboratory test. We can make survey during the borehole progress drilling. What? Usually we do in wireless system, but we can do also in coring system standard. We can do dilatometric test. We can do video photographic recording, temperature control of the water. We can do permeability test, Lugeon, Lefranc, and we can also install instrumentation fully from SISGEO, but not necessarily. So the grouting parameters record give us information about the feature of the soil, the stop, why the grouting stop. It gives information about the mechanical feature of the rock that we are going to grout. The volume, eventual volume decrease over time can give us information about the presence of void or high permeability layers. The grouting time, the filling time, give us information about the layers and the evolution of the pressure, of the volume, of the flow rate during the drilling can give us information about the possibility to introduce the claquage phenomena. We can apply monitoring system also in foundation. When we apply moreover in 3-4 cases. Inclinometric pipe can be placed together with the cage for the monitoring of the diaphragm wall or piles. This deformation control during the excavation phase, in example for car parking or subway, give information about the deformation that we have. We can place strain gauges for a compressed element. The deformation that we can collect give us information about the compression load. Load cell can be mounted also in a tensile effort, but working for compression effort. So in tie rod, we can apply some load cell that give us information about the state of the anchors during the time. The conclusion are easy, is a message, very, very simple, because the accuracy that we can put inside the technology for the production and the testing of the system that we bring on site for the monitoring, for the geotechnical monitoring, is not useful if we don't put the same care, attention, and overall view for the application of this instrumentation inside the soil. Is a couple of elements that need to work together. Otherwise, we cannot guarantee a good solution for a long time. So, good instrument for good application. Thank you.
Thank you very much, Gianluca, for your extensive overview of all different types of methods for soil drilling and grouting, including monitoring and control. Thank you. And now we go on to the final presentation before lunch, and that's another partner presentation will be given by Michael Vucic, and it is about DATC and GeoD, 20 years of cooperation through development and innovative solutions. We are curious about that. The floor is yours.
Yep. Good afternoon. My name is Michael Vucic. I'm on one side, I'm a very lucky man because I finished a study in Kraków on the mining academy, and all my business life I spent in the drilling technology, what is not so often today. So after some experience, I start to think to have the own company and own development of market. Our first partner was DATC Europe, and DATC is a family company based on 1974, and basically he was in Switzerland, but because of the European regulation problems with export, they moved to France. This is, as I say, it's a family company. Clearly based on the quality. All the product is French product, European product, and we understood that the quality for the sampling, coring, is the first point, because that's the biggest influence for the future result. DATC has the three main location, one in Germany, the base is in Besançon, and also office in France. So the GEOD, it's started in 1995, and that is a family company, start from the simple development of coring systems, and we, how to say, we believe that going with the proven high technology, all improvement, new research, it is only one way. So this looks simple, and this is the idea to show you, because this is our building, new office. looks normal. But what the people say before about the geothermal energy, we have the 16 holes, 55 kilowatt energy from the ground. On the roof, we have the solar battery, and we have also photovoltaic panel. So in our life, in our business, we are realizing the idea of zero emission. This building, it's not the zero emission because we have some machinery, it is impossible, but for the normal life, it's a low emission building. And this is our strategy, not only in the business, but also in our life. I will give you 3 examples how we can work. The first example is from the beginning of our cooperation between the DATC and GEOT. It was the Świnna Poręba Dam, that's the longest construction dam in Poland, 30 years. And at the end, they was drilling for the injection curtain, and the problem was that the bits, what they was used, was consumed very fast. So we developed the special bits. The first was the problem that the rocks was very abrasive, and the bit life was very short, not because we lose the diamonds, but because we lose the body of the bit, because of the abrasivity of the cutting material. So we developed the special bit, and until end of the dam construction, they was working only with our bits. That was a small example from 1995, 1996. So then the example from another years, we have that was the PRGW company. Now it's a new name, United Oil Well Services. And they ask us to build a special core barrel to work on the deep holes for the gas storage in salt and to exploitation of the salt. And the location was the Góra near Inowrocław. The problem was that they have the sample, but because of the long process, this sample was destroyed at the end when they have this on the surface. So we increased of the drilling using the special core barrel. That was the first PWL 165 millimeter, and later on CSK 165. We increased the speed and we increased the quality of the core. And let's say that was the heavy duty core barrel working until now. We also multiplied this project. We was working in Romania. We was working in Austria for Salinen mine. And the core barrel, it's a special, it's up to 3,000 meter. Our record was 2,800 meter. But this is example that we start from the simple bit, and after a few years, we was able to produce the professional deep hole core barrel, of course, with our partners from France, and that's the result. You can see the core sample, and this was not the pieces, it's a full piece. Let's say on 9 meter length core, we have 2-3 pieces. Even sometimes we got 1 piece. So then it was the process for the geologists to cut it, to pack, to store. And then the last example of our cooperation. It's a cryogenic core barrel. Let's say in the modern town, we have the geological, geotechnical problems. It is a lot of polluted area where we have the different pollution, and to remediate it, we need a proper sample. And in this specific condition, the question was to have the sample with the real gas content. It was a couple of gas, but the problem was when they analyzed this underground in the hole, they have specific gas contamination. When they put the sample to make a test in the laboratory, that was half of this, even less. So the idea of the core barrel is to drill, and the core barrel has the three systems. Have the inner tube with the sampler, the outer tube, and in between we have this spiral system, and this is connected to the surface. And then after sampling, we are put the nitrogen and cold and make the frozen sample. Of course, the structure of the sample is destroyed, but because of the freezing the sample, we have the full set of the pollution what we have in the ground. So this is the drawings, and let's say that's what I would like to show. It's not so many things, but this is our target, what we are doing, to be always professional and to work with our customer and let's say deliver not only the product, but the know-how and the support. Thank you for attention.
Thank you very much, Michael, for these nice examples to share with us very innovative solutions through cooperation. Thank you very much for sharing this with us.